Hello students and good morning. So now I am doing class for class 12 science. So this is the continuation class for the chapter standard integrals, and in the last online class we were doing the same chapter, that is standard integrals. So today also we'll do the same chapter, standard integrals. So this is from exercise 6b, but this is from the new section, that is 5 mark section, page number 363 from the book Higher Mathematics for Class 12 by Sailendra. So in the next online class we finished 4 mark section. Okay, so now we are doing this 5 mark section type question. So integrate. So question number 1 is integral sine px plus q divided by root under x square plus r square dx. Okay, so now in this case, the numerator, in the numerator the highest power of x is 1, that is px plus q is there. This is known as linear expression in x, and within square root there the power of x is 2. This is known as quadratic expression in x. But in the denominator we don't have the term containing x to the power 1, that is we don't have the expression containing x. So in this case directly we can separate the term and then we can easily integrate them. But if there is term containing x also, x square term, if there is term containing x also, then the differentiation of the expression within square root should be written in the numerator as we have done in the previous problem. त यहाँ मैले के भन्न खोज्दैछु भन्दाखेरि यो जुन चाहिँ डिनोमिनेटर मा टर्म छ x स्क्वायर र कन्स्ट्यान्ट मात्रै छ, x स्क्वायर र कन्स्ट्यान्ट टर्म मात्रै छ भने हामी के गर्छौं, डाइरेक्ट यसलाई छुटाउँछौं. यदि यहाँ x स्क्वायर को टर्म पनि x को टर्म पनि अनि कन्स्ट्यान्ट टर्म पनि छ भने स्क्वायर रुट भित्रको डिफरेन्सिएसनलाई हामी केमा लेख्छौं, न्युमरेटरमा लेखेर हामीले त्यसलाई इन्टिग्रेट गर्न सक्छौं. ठीक छ. तर यहाँ डिनोमिनेटरमा देयर इज नो टर्म कन्टेनिङ x टु द पावर 1, that is there is no term containing x, but this expression contains only x square and r square. So directly we can separate the term here. Okay, so therefore I is equal to integration of, this is px plus q divided by root over, this is x square plus r square dx. Okay, is that clear? Now we can separate the term here. Okay, so or I is equal, let us separate the term. So directly you can separate integral sine and dx also. P is constant, p integral sine x dx divided by root over x square plus r square plus, now in this case q is constant, is taken outside, integral sine dx divided by root over, this is your x square plus r square. So I think you have understood it. So let us mark it as I1 and this as I2, or directly you can integrate it. Okay, so here you have to do the method of substitution. In this case you know that, suppose this is I1 plus, you can directly use the standard integral here. So q into, what is integration of dx divided by root over x square plus r square. So this is in the form, in this integral form, this is in this integral form, that is integration of dx divided by root over x square plus a square. Here x is the variable, a is a constant, so we can use the formula log within mod x plus root over x square plus a square mod sign closed, the base is e, then plus c. So now let us compare this integration with that standard integral. Instead of x there is x, instead of a there is r. Okay, so we can use that standard integral here. So plus q into, what is the formula, log within mod, here x is x plus root over, what is x square plus a square, x square plus r square mod sign closed, the base is e, then what do we write, plus c. Is that clear? Now let us find out the value for I1 now. So we have used the formula for this second integration, this is the standard integral, so we have used it. So now let us find out the integral I1. Okay, so let I1 is equal to P integration of x dx divided by root over x square plus r square. Okay, so now what will you do here now? So now differentiation of x square will be 2x, and for r square it is 0. Differentiation of x square is 2x, plus for r square, that is constant, it is 0. So let us assume z square is equal to x square plus r square. So let z square is equal to x square plus r square. Let z square is equal to x square plus r square, because the expression is on the square root and it is in the denominator. So if the expression is on the square root and if it is in the denominator, I already told you that, so in order to integrate it, you have to assume the expression within square root as z square. Okay, so let z square is equal to x square plus r square. So let us differentiate both the sides with respect to x. So differentiating both the sides with respect to x. So therefore, what is the differentiation of z square? 2z into dz by dx is equal to 2x. So here 2 gets cancels. So cross multiply, z dz is equal to x dx. So it is z dz is equal to x dx. Is that clear? So let us put these values in I1. So I1 is equal to, now here it is p is constant, you have to write it. Integral sign. What is x dx? Z dz. Z dz divided by, this is root over z square, isn't it? So it is root over, this is z square. So or I1 is equal to p integral sign, this is z dz divided by, what is root over z square? That is your z, z gets cancels. Or I1 is equal to p integral sign, this is dz. Okay, this is p integral sign dz. Okay, so what is integration of dz? That is your z. So I1 is equal to p, you have to write down p as constant. So what is integral sign dz? That is your z, then what do you write? Plus c. Or I1 is equal to p into, now you have to put the value for z. What is z actually? Since z square is equal to x square plus r square, what is the value for z? It is root over x square plus r square. Then it is plus c. So this is the value for I1. So let us put these values of I1 in I. Okay, so this I is equal to, since write down, since I is equal to I1, then we have plus q log within mod, there is x plus root over x square plus r square, mod sign closed, the base is e, then plus c. So actually this is the value for I. So in this value of I, so we have copied this expression, that is the value for I, that is I is equal to I1 plus q log within mod x plus root under x square plus r square, mod sign close, the base is e, plus c. So in these values of I, let us put the value for I1. Okay, so or I is equal to, what is I1 here? It is p root over, this is x square plus r square plus, then this is q log within mod x plus root over x square plus r square, mod sign closed, the base is e, then plus c. So this is the final answer. So I think you have understood it. So this question is very, very important. You can copy it. Okay, so now we'll do the next question. So now we'll do the next question, that is question number 2 from 5 mark section. So the question here is integral sign. In the numerator we have 2x plus 3 dx divided by Within square root there is x square plus 4x plus 5. So how will you integrate this integral? Okay, so now in the denominator there is term containing x square, term containing x is also there, there is also constant, so you cannot separate the term in this case because there is term containing x also. Okay, so we cannot use the previous questions method in this case. Okay, so in this case we will use the different methods because there are terms containing x square and x and constant in the denominator, and that is also on the square root. Okay, so let us write down the differentiation of the denominator in the numerator. So within square root we have x square plus 4x plus 5. So let us write down the differentiation of this denominator which is on the square root in the numerator. तो यहाँ हामी के गर्छौं भन्दाखेरि स्क्वायर रूट भित्रको जुन चाहिँ एक्सप्रेसन छ x स्क्वायर प्लस 4x प्लस 5 यसको डिफरेन्सिएसन चाहिँ हामी न्युमरेटरमा लेखेर गर्छौं. So therefore let us write first I is equal to integration of this is 2x plus 3 dx divided by root over this is x square plus 4x plus 5. Okay, so or I is equal to integration of, now within square root there is x square plus 4x plus 5. So what is this differentiation? So let us write down the differentiation of x square plus 4x plus 5 in the numerator. So what do we get? Differentiation of x square is 2x plus differentiation of 4x is 4 and plus 5 it is 0. So it is put within bracket. But in this case we have 2x is correct, that is correct, but here it is 4 but there is 3. So what will you do? Let us write minus 1. So if it is 4 minus 1 then it is 3. So whole divided by within square root this is x square plus 4x plus 5. Then what do you write? Dx. So I think you have understood it. So let us separate the term in this case. Or I is equal to integration of this is 2x plus 4 into dx divided by root over this is x square plus 4x plus 5, then minus integration of dx divided by this is root over this is x square plus 4x plus 5. Is that understood now? So let us write it as I1 minus I2. So first integration is written as I1, there is minus, and second integration is written as I2. So this is your I1 minus I2. Okay. So now let us first find out I1. Let I1 is equal to integration of this is 2x plus 4. So 2x plus 4 dx, 2x plus 4 into dx divided by root over this is x square plus 4x plus 5. So this is x square plus 4x plus 5. Okay. So now what we will do here is that you have to do the method of substitution because the expression on the square root is x square plus 4x plus 5. If you differentiate it, we are getting the numerator. Okay, so let us assume the expression on the square root as z square because the expression is on the square root and it is in the denominator. So we can assume let z square is equal to x square plus 4x plus 5. Is that clear? So let us differentiate it. So differentiating both the sides with respect to x. So now what is the differentiation of z square with respect to x? 2z into dz by dx is equal to, for x square it is 2x plus 4x it is 4. Now we can do cross multiplication. So it is 2z dz is equal to this is 2x plus 4 into dx. So now this is the method of substitution as we have done in the previous chapters. Okay. So what is I1 now? So therefore I1 is equal to integration of what is 2x plus 4 dx? It is 2z dz, right? divided by, this is root over z square. What is root over z square? That is z gets cancels, or I1 is equal to, this is 2 integral sine dz. This is 2 integral sine dz. Okay. So what is I1 now? So therefore I1 is equal to 2z plus c, or I1 is equal to 2 into, what is z? What is the value for z actually? Since we have assumed z square is equal to x square plus 4x plus 5. So what is the value for z here in this case? It is root over, this is your x square plus 4x plus 5. Then what do we write? Plus c. So we have got the value for I1. Okay. So now let us get the value for I2 now. So let I2, what is I2 now? What is I2 here? It is integration of dx divided by root over, this is x square plus 4x plus 5. Is that clear? So now the expression is on the square root and the coefficient of x square is positive, but the expression cannot be factorized. You cannot do the middle term breaking out here. Okay? So directly you have to convert into standard integral form. This x square plus 4x can be written in terms of a square plus 2ab plus b whole square. Okay? So let us convert into perfect square form now. So, or I2 is equal to integration of dx divided by within square root. Now already the coefficient of x square here is positive. Okay? So convert into, it is positive 1. The coefficient of x square is positive 1. So first of all, the coefficient of x square should be positive 1. So it is already positive 1. So let us convert into a square plus 2ab plus b square form. What is a whole square? X square plus 2 into, what is a? X into, what should be the value for b? That is 2. So that it is 4x. Plus, what is b whole square? That is your 2 whole square. That is 2 whole square is 4. But is there 4? No, you have to subtract it. What there is 5, so you should write plus 5 first, then you write minus 4. Okay? So, or this is I2 is equal to integration of dx divided by within square root. So what is the formula you can use here? This is x plus 2 whole square plus, what is 5 minus 4? That is 1. So you can write here 1 whole square. Is that clear? So now this is the standard form. So which standard form is this one? This is the fourth standard form. You should know that. That is integration of dx divided by, instead of x there is x plus 2. Instead of a there is 1. So it is root under x square plus a square. So what is integration of dx divided by root under x square plus a square? That is log within mod x plus root under x square plus a square. Okay. So let us write down the formula now. So or I2 is equal to log within mod. Here the base is e. What is x? It is x plus 2 plus root over, what is x square plus a square? This is x plus 2 whole square plus 1 whole square. Mod sign closed. Then what do we write? Plus c. So let us simplify the expression on the square root. Or I2 is equal to, this is log, the base is e, mod sign x plus 2 plus root over. Now what is x plus 2 whole square? This is your a plus b whole square. So it is x square plus 4x plus 2 whole square is 4 plus 1, mod sign closed, plus c. Okay. So or I2 is equal to, what is I2 now? Log base e within mod x plus 2 plus root over, this is x square plus 4x plus 4 plus 1 is 5, mod sign closed, plus c. So we have got the value for I2. Okay. So we have got both the values of I1 and I2. So let us put these values of I1 and I2 in I. Yo I malnu paryo. So let us write here, since I is equal to I1 minus I2. So let us put the value now. So I is equal to, what was the value for I1? I1 is this one. So 2 root over, this is your x square plus 4x plus 5. Now in this case, you don't have to write this plus c. 1c will do, okay? Only you have to write only one constant of integration, that is c, okay? So don't write again plus c out here, okay? So this is the value for I1. त हामीले यो दुईटै c लेखिरहनु पर्दैन, एउटा c लेख्यो भने भइहाल्छ, ठीक छ? So this is the value for I1, that is 2 root under x square plus 4x plus 5 minus I2. What is minus I2? Minus log, the base is e, within mod x plus 2 plus root over, this is x square plus 4x plus 5 mod sign closed plus c. So this is the final answer. So I think you have understood it. So this question is very, very important. So you can mark it, okay? So you can copy this problem. Now we will do the next problem. So now we'll do the next question, that is question number 3, number 1. You have to integrate, okay? That is integral of 2x dx divided by root under 1 minus x square minus x to the power 4. So how will you do it? So in this case, first of all, you have to do the method of substitution. So there is 2x in the numerator. So differentiation of which function may be 2x? It is x square, isn't it? Differentiation of x square is 2x. So let us write here first, I is equal to integration of, this is 2x dx divided by root over 1 minus x square minus x to the power 4 can be written as x square whole square. Okay? So let us assume z is equal to x square. So let z is equal to x square. So let us write here differentiating both the sides, with respect to x. So therefore dz by dx is equal to 2x. Now you can do cross multiplication, dz is equal to, this is 2x dx. That means the value of 2x dx is dz, right? So therefore what is I? So I is equal to integration of, what is 2x dx? It is dz divided by, in the denominator we have root over 1 minus, what is x square? It is z, minus what is x square whole square? It is z square. So now we have got integration of dz divided by root over 1 minus z square. The expression is under square root and there is 1 in the numerator. So in this case, there is term containing z square and z. You have to convert into perfect square. It may be a square plus 2ab plus b square, or it may be a square minus 2ab plus b whole square. So before that, always make the coefficient of z square positive 1. I already told you that one, isn't it? So in order to convert into perfect square form, always make the coefficient of z square positive 1 by taking common, right? So therefore, this is I is equal to integration of, this is dz divided by root over, here minus is taken common, within bracket z square, minus into minus plus z, minus into minus plus z, then minus 1. So here bracket is closed. You cannot take that minus 1 outside because square root of negative number is always undefined or imaginary. So let us keep it as it is. Let it be in the denominator minus, okay? So let us convert this z square plus z in the form of a square plus 2ab plus b whole square. So or I is equal to integration of, this is dz divided by within square root, this is minus within second bracket. What is a whole square? This is z whole square plus 2 into, what is a? Z into, what should the value for b, so that we can have only z. So these 2 should be cancelled, so it is half, plus what is b whole square? This is half whole square, Is that clear? So next, we are getting z square, that is correct. This is also 2 gets cancelled, we are getting z. But this is half whole square is 1/4. But is there 1/4? No. So it is minus 1 minus 1/4. Minus 1 minus 1/4. Is that clear? So you have to write down this minus 1. But half whole square is 1/4. There is no 1/4. So you have to cancel it. So you have to write minus 1/4. Is that clear? So let us simplify it further. Or I is equal to integration of this is dz divided by within square root minus within second bracket. Now this is a square plus 2ab plus b whole square. What is the formula? A plus b whole square. So this is z plus half whole square. Is that clear? And what is minus 1 minus 1/4? Same sign, you have to add them. So it will be 4 ones are 4 plus 1 is 5. So it is minus 5/4. So this is minus 5/4. Now let us multiply by minus sign here. Or I is equal to integration of this is dz divided by within square root. This is minus into minus plus. This 5/4 can be written in terms of whole square. That is your a whole square. Here is root over 5/2 whole square. Okay. So this is minus into minus plus. So positive term is written first. Then minus. So it is z plus half whole square. So it is z plus half whole square. Okay. So here the value for a is root 5/2. And what is the value for x? It is z plus half. So what is the formula? It is sine inverse x upon a. That is the 6th standard form. That is integration of dx divided by root under a square minus x square is equal to sine inverse x upon a. So here x is z plus half and here a is root 5/2. So or I is equal to this is sine inverse within bracket x by a. What is x by a? This is z plus half divided by root 5/2 bracket closed plus c. Okay. So what is the LCM in the numerator? 2 is the LCM and that 2 and this 2 will be cancelled. So what do we get? Or I is equal to, you will get sine inverse within bracket 2z plus 1. This is 2z plus 1, isn't it? 2z plus 1, this 2 will be cancelled upon root 5. Upon root 5 bracket closed plus c. Is that clear? So what is the value for z in this case? The value for z in this case is x square. So or now this is I is equal to sine inverse within bracket 2z here is x square. Z is equal to x square. So we put the value for z, that is x square plus 1 divided by root 5 bracket closed plus c. So this is the final answer. So I think you have understood it. So you can copy it. Now we'll do the next question. So now we'll do the next question, that is 3 number 2. You have to evaluate this integral. The question is integration of 5 minus 2x divided by root over 5 plus 4x minus x square dx. So in the numerator the highest power of x is 1, that is linear expression in x. And in the denominator within square root there are terms containing constant x and the power of x is 2, that is your quadratic expression. So in this case the differentiation of the denominator which is on the square root is written in the numerator. तो यहाँ के गर्छ हामी यो जुन चाहिँ स्क्वायर रुट भित्र एक्सप्रेसन छ त्यसको डिफरेन्सिएसन चाहिँ हामी न्युमरेटरमा लेखेर यो इन्टिग्रेसन गर्छौं. ठीक छ? So therefore I is equal to integration of this is 5 minus 2x bracket close dx divided by root over this is your 5 plus 4x minus x square. Okay. So let us write down the differentiation of the expression which is on the square root in the numerator. Okay. The square root भित्र जुन चाहिँ expression छ त्यसको डिफरेन्सिएसन चाहिँ हामी न्युमरेटरमा लेख्छौँ, ठीक छ। सो और I is equal to integration of what is the differentiation of the denominator on the square root, that is differentiation of 5 is 0, you don't have to write it, plus what is the differentiation of 4x with respect to x, it is 4, and minus what is the differentiation of x square, it is 2x bracket closed. Okay, but we have got 4 minus 2x, but there is 5 minus 2x in the numerator. You should have 5 minus 2x in the numerator. Okay, so minus 2x is correct, that is variable is correct, but there is 4, but here we have 5. To make it 5, what will you write? 4 plus 1 is 5 divided by within square root, this is 5 plus 4x minus x square, then what do we write? Dx. Is that clear? Now we can separate the term, or I is equal to, let us separate the term, integral sign, this is 4 minus 2x bracket close dx divided by, this is root over 5 plus 4x minus x square. This is the first term. What is the second term? Plus sign is there, plus integral sign 1 into dx is dx divided by, this is root over, this is 5 plus 4x minus x square. Is that clear? So let us write it as I1 and I2. So first integration as I1, so I is equal to I1 plus this is I2. So I is equal to I1 plus I2. Okay, so let us write I1 is equal to, let I1 is equal to, what is I1? Integration of, this is 4 minus 2x dx divided by within square root. What do we have within square root? 5 plus 4x minus x square. 5 plus 4x minus x square. So I think you have understood it. Okay. So what is the method for integrating this I1? That is, if you differentiate the expression on the square root, you will get the numerator, isn't it? So that means in this case you have to do the method of substitution. But I already told you that the expression is on the square root and that is also in the denominator. So we can assume z square. So let this is z square is equal to 5 plus 4x minus x square. So differentiating both the sides, differentiating, that is differentiating both the sides with respect to x. So what is the differentiation of z square with respect to x? It is 2z into dz by dx is equal to plus 4x. It is 4 minus x square is 2x, or this is 2z dz is equal to, this is 4 minus 2x into dx. So we have got the value of the numerator, that is within bracket 4 minus 2x dx is equal to 2z dz. Okay. So therefore, what is I1 now? So I1 is equal to, this is integration of, what is 4 minus 2x dx? It is 2z dz divided by, what is root over, this is z square, isn't it? What is root over z square? That is z. Z gets cancels. So or I1 is equal to, this is 2 integral sine dz. Is that clear? Or this is I1 is equal to, this is 2z plus c, or I1 is equal to 2 into, what is the value for z? What is z in this case? It is root over 5 plus 4x. It is root over 5 plus 4x, 5 plus 4x minus x square plus c. So we have got the value for I1. So let us get the value for I2 now. What is I2? I2 is this integral. Let us write it here. Let, what is I2 now? I2 is equal to integral sine dx divided by, this is root over 5 plus 4x minus x square. 5 plus 4x minus x square. So actually there is 1 in the numerator, 1 dx divided by root under 5 plus 4x minus x square. So here the expression is under square root, and this is the quadratic expression, and the coefficient of x square is negative. Don't factorize it, just convert it into standard form. Before that, convert it into perfect square form, and before that, make the coefficient of x square positive 1. Okay, so we can take common here, or I2 is equal to integration of, this is dx divided by within square root. So in this case, minus is taken common to make the coefficient of x square positive 1. Okay, so here minus is taken common, so it is x square minus into plus minus 4x minus into plus minus 5. Okay, so or I2 is equal to integration of dx divided by within square root. So after making the coefficient of x square positive by taking minus common, so you can express this x square minus 4x in terms of perfect square, that is a square minus 2ab plus b whole square. So it is minus within second bracket, what is a whole square, x whole square minus 2 into x into what should be the value for b, that is your 2, so that it is 4x plus what is b whole square, this is 2 whole square. Okay, but is there 4? No, you have to cancel it. First you write minus 5, so minus 5, then write down minus 4. Your second bracket is closed. So you have to write down this minus 5 because there is minus 5 here, but 2 whole square is 4, there is no 4, so subtract it, minus 4. Okay, so or I2 is equal to integration of, this is dx divided by within square root minus within second bracket. So now you know this formula, a square minus 2ab plus b whole square. What is the formula? It is x minus 2 whole square, and minus 5 minus 4 is minus 9. So here second bracket is closed. So or you can write it as I2 is equal to integral sign dx divided by root over, let us multiply by minus sign here, minus into minus plus 9. So 9 here is 3 whole square minus x minus 2 whole square. So here instead of x there is x minus 2, and instead of a there is 3. So this is integration of dx divided by root over a square minus x square, which is the 6th standard form, and its formula is sine inverse x upon a. Instead of x there is x minus 2, instead of a there is 3. So what is the value for I2 now? So this is I2 is equal to, this is sine inverse x by a, that is x minus 2 upon 3 plus c. So we have got the value for I2. Okay, so now what will you do in the next step? Let us put these values of I1 and I2 in I. So actually what is I? You have to get the value of I, that is the answer. So I is equal to I1 plus I2. So let us write here, since I is equal to I1 plus I2, or this is I is equal to, what is I1? Let us first write down I1. So it is 2 root over, it is 5 plus 4x minus x square. You see no leginba. Yoda c lekam chalihalcha, 1c will do. Okay, then plus what is I2? Let us write I2. So sine inverse x minus 2 upon 3, then plus c. So this is the final answer. The एउटै c लेख्यो भने भइहाल्छ. ठीक छ, हामीले दुईवटा c लेखिरहनु पर्दैन. So this is the value for I. So I think you have understood it. So you can copy it. Now we'll do the next question. So now we'll do next type of question, that is question number 4. You have to evaluate this integral. That is integration of within square root. Within square root there is a fraction, that is 2 plus x divided by 2 minus x dx. So this is different type of problem. So how will you do it? This is different type of problem. So how will you do it? So now in this case, remove square root from the numerator. Let us remove square root from the numerator. So how can you remove square root from the numerator? So first of all, you write I is equal to integration of root over, this is 2 plus x, 2 plus x, this is your 2 plus x divided by 2 minus x dx. Okay, so let us remove square root from the numerator. So how can you remove square root from the numerator? So in the numerator there is 2 plus x. It should be multiplied by 2 plus x. So that will be 2 plus x whole square, and square root of 2 plus x whole square. You can remove that square root and square, isn't it? So in this case you multiply both the numerator and the denominator by 2 plus x. Okay. So or I is equal to integration of within square root. So this is 2 plus x whole square divided by, this is 2 minus x into 2 plus x, bracket close, then what do we write? Dx. So I think you have understood it. So in order to remove square root from the numerator, we have multiplied both numerator and the denominator by 2 minus x, and we got this expression, that is within square root it is 2 plus x whole square divided by 2 minus x into 2 plus x. Okay. So or I is equal to integration of, now you can remove square root from the numerator. So this will be 2 plus x dx divided by root over, this is 4 minus x square, because this is a plus b into a minus b. What is a minus b into a plus b? A square minus b square. So which is equal to 4 minus x square. Okay. Now in the numerator we have the highest power of x is 1. That is, it is linear expression in x. So we have got only 2 plus x in the numerator. And in the denominator we have the term containing x square and only constant, and there is no term containing x to the power 1, that is x. Okay. So I already told you the method. Directly you can separate it. If there is no term containing x to the power 1 in the denominator, if there is no term containing x to the power 1 in the denominator, if there are only the terms containing x square and constant, you can directly separate this expression. Okay. So let us directly separate this expression. Or I is equal to, here 2 is constant, it is taken outside, 2 integration of, this is dx divided by root over, this is your 4 minus x square. Is it clear? Next, plus integration of, next, this is x dx. So fraction and both integral sign and dx are separated. X dx divided by, this is root over 4 minus x square. So I think you have understood it. Okay. So for the second integration you can do the method of substitution, and for the first integration directly you can use the standard integral. So or this is I is equal to 2 integral sign dx divided by, this is root over, how can you write down this 4? This is 2 whole square minus x square plus, so let us mark it as I1. Okay. So or I is equal to 2 into, this is directly standard integral, that is integration of dx divided by root over a square minus x square. Instead of a there is 2, instead of x there is x only. So what is the formula? Sine inverse x by a. So it is sine inverse, what is x by a? It is x by 2 plus I1. Is that clear? So let us get the value for I1 now. So what is I1 here? Let I1 is equal to integration of, this is x dx divided by root over 4 minus x square. So in this case we can do the method of substitution as we have done in the chapter integration by the method of substitution, because within square root there is 4 minus x square. If you differentiate this 4 minus x square, you will get minus 2x. That means we are getting x, isn't it, which is in the numerator. And since the expression is under square root and it is in the denominator, we can assume z square. So let us assume, let z square is equal to 4 minus x square. Okay? So differentiating both the sides with respect to x. Differentiating both the sides with respect to x. So what do we get? What is the differentiation of z square? It is 2z dz by dx is equal to minus 2x. Because for 4, differentiation of 4 with respect to x is 0, and for x square, differentiation with respect to x is 2x. So from both the sides you can cancel this 2, or so it is z dz is equal to minus x dx. And now in this case we have got x dx. Let us take this minus sign to the left hand side. So minus z dz is equal to, this is your x dx. So we have got the value for x dx, which is equal to minus z dz. So let us put these values in I1. So therefore I1 is equal to integration of, this is integration of, what is x dx? Minus z dz. This is minus z dz divided by, this is your root over z square. What is root over z square? That is your z. So here z gets cancels. So or this is I1 is equal to, minus sign is taken outside, integral sign dz. Minus sign is taken outside, so it is integration of dz. What is integral dz? That is your z. Okay. So I1 is equal to minus z plus c, or I1 is equal to, what is minus z? This is minus sign, you have to write minus. What is the value for z? Z square is equal to 4 minus x square, so it is under root. So it is square root of 4 minus x square plus c. But this is the value for I1. Okay. So actually we have to get the value for I only. Isn't it? We have to get the value for I. So let us put these values of value of I1. Let us put this value of I1 in I. So let us copy it. What is I here? So I is equal to, first expression is 2 sine inverse x by 2. 2 sine inverse x by 2. Then we write plus I1. Then we write plus I1. Okay. So or I is equal to, this is 2 sine inverse, this is your x by 2 plus, what is I1? So actually I1 is minus, so plus into minus is minus sign, so let us write here minus sign. So it is minus root over 4 minus x square plus c. So this is the final answer. So what is the value for I in this case? It is 2 sine inverse x by 2. Plus into minus is minus. What is I1 here? Root over 4 minus x square, then plus c. So this is the final answer. So I think you have understood it. So you can copy it. So this much is for today. त आज पनि हामीले जति पनि प्रब्लम्सहरु गर्यौं सबै इम्पोर्टेन्ट छ, यो सबै घरमा रिभिजन गर्नु. So in the next online class we will do more problems on the standard integrals from the 5 mark section. So this much is for today.